Solving Quadratics Part 1. On our agenda, we're going to talk about what does it mean to solve a quadratic, how do we solve by graphing using the table and calculator, how do we solve using square roots, and how do we solve by factoring. So let's get ready. You're going to need your notes, your pencil, and your calculator. And what does it mean to solve a quadratic equation? Well, the solutions to a quadratic equation are where it equals 0, and that would be on the graph. So notice this is set to 0, so if it's not already set to 0, it should be. It should be in standard form, which means you start with the x squared, then the x to the 1, and then the constant. And you're looking for where the graph crosses or touches the x-axis, so those x-intercepts. These would be the solutions. They can also be called roots or zeros. So let's think about how many solutions we could have to our quadratic. If I have kind of a normal quadratic that's going to cross at two places, we would say that this will have two real solutions. If it's just touching the axis, the x-axis at one spot, that's called tangent. It touches it and turns around and goes back. So this will have one real solution. And then the other scenario is it could be above and open up so that it never touches the x-axis. So we're going to say this has 0 real solutions. That means it's going to have 2 imaginary solutions. And we'll work on those in another lesson. So what we're going to look at is I've grouped these into part 1, which is graphing with and without a calculator, square roots and factoring. That's today's lesson. Then we'll look at completing the square and quadratic formula. So if we have all of these strategies, some of them will work all of the time, some of them will only work some of the time, but it would be quicker than another method if it's going to work. So graphing will work if you do have a calculator all the time. If you have graph paper, if you're just graphing by hand, you might not come out to an exact answer. Square roots will work some of the time, and we'll look at when that's going to happen. And then factoring will work sometimes. Not everything is factorable. Completing the square will always work, and quadratic formula will always work. So let's start by graphing here. And remember that this is in standard form. So in order to graph, I need the little x equals negative b over 2a to find the vertex. So in this case, x equals negative 4 over 2 times 1, which is going to be 2. That's the x of the vertex. So I'm going to plug that back in to figure out y of the vertex. And that comes out to be 0. So my vertex is the point 2, 0. I know that my last term, my c value, is my y-intercept. So I'm going to go ahead and graph. I know I go through, oops, that's supposed to be a 4. 0, 4, 1, 2, 3, 4. And my vertex is at 2. That does make sense because my a is 1. If I check my step pattern, up 1, over 1, up 3, over 1, and then I would be symmetrical there. So I have graphed it using x equals negative b over 2 and my y-intercepts. And my only x-intercept is 2, 0. So that is my answer. Pause and try this one. All right, well, it is in standard form. It is set to 0, so that's good. I'm going to go ahead and find the x of my vertex. So that's negative 6 over 2 times negative 2, which is 3/2. I'm going to find the y of my vertex. And that becomes, let's see, negative 2 times 9/4 plus 18/2, which is negative 18/4. Get a common denominator, so 36. So 18/4, which is 9/2, which is 4.5. So my vertex is 1.5, 4.5. And my y-intercept is 0, 0, which then also becomes an x-intercept. So I'm going to graph this, and I know I go through 0, 0. I am over 1.5, 1, 2, 3, 4 up there. Again, I don't have perfect graph paper. So if this is my axis of symmetry, and this is 1.5 away, then this is, no, sorry, yeah, 1.5 away. Then this would be 1.5 away at 3 to be symmetrical. So my answers here are x equals 0 and x equals 3. Solve by graphing with the calculator. So you want to, this is equal to 0. I can now enter it into my calculator as y equals that. Go ahead and graph that. And you should see that we cross at the 1 and the -1 and the 3. If you check out your table, you can see that you're looking for when when y is 0. You can also go to your calculator and you can do second trace 0 because these are our zeros. And then you can go to the left side of that point and the right side, and that would give you -1. And then you have to go to the left side of this and the right side of this. So again, it's the left enter, right enter, guess enter that we were doing with our min and our max. But this time, make sure you're picking the 0. So you can solve by looking at the table. That will work if it's integers. If it's not, then you have to rely on second trace 0, left, right, enter, and then it will tell you your x-intercepts. All right, solve by square roots. So we're switching methods. Let's take a look at what we have. First, it's not in standard form. I'm actually going to use that to my advantage because if you notice, there is no x to the 1. So solving by square roots might work when b is 0. That would be a good time. So if b is 0, then I don't have any just plain old x. So if something is squared, I can undo that by taking the square root. So that's what I'm going to do. I'll solve this by taking the square root. Really important to remember your plus or minus. So you might just say x equals 7. Well, if I think about that and I graph this, so this is going to be y squared minus 49, which is a graph that shifted way down 49. So let's say we're way down here. This is going to come up on the 7, right? There's my parabola. But you forgot to tell me the other answer, so you definitely need that plus or minus. This has 2 answers, and I can graphically check it and prove that. So my answers here would be x equals plus or minus 7 as intercepts 7, 0, and -7, 0. So let's try this. If I undo this, so because you notice that b equals 0 here, I'm going to subtract the 3 over. I get 72, divide by 2, I get 36. X equals plus or minus 6 because I remember to take the square root and the plus or minus. Pause and give this one a try. Okay, so I'm going to get the x squared by itself. I'm going to subtract 1. I'm going to divide by the 3, so I get 50. And then I'm going to take the square root of both, remembering the plus or minus. And it is a square root, so I should simplify. That has a perfect square of 25, so it's going to become 5 root 2, plus or minus 2 answers. That is the exact answer with the square root. Here's a special scenario. Note there. This is not in standard form. It is set to 0. Again, I can use this to my advantage if I recognize I see the square, there's no other x around besides what's inside. So what I'm going to do is I'm going to add the 8 over. And it's kind of like what we just did, the left side squared, so I can take the square root. Remember the plus and minus on the 8. So that undoes my left side. So now I have 4x plus 1 equals plus or minus 2 root 2 when I simplify the square root of 8. I'm going to subtract the 1. -1 plus or minus 2 root 2. I like to put that in front just so it doesn't get stuck under the square root sign. And then divide everything by 4. We are going to have to simplify here. So I would like you to separate your fractions. So we're going to get x equals -1/4 because the 4 goes under the -1. And then plus or minus 2 root 2 over 4. This piece can be simplified. So it becomes -4 plus or minus root 2 over 2. Those would be my 2 exact answers. Pause and try this. And this one is again set up for square roots. I can take the square root of left, square root of the right, remember the plus and minus. And I have 2x plus 3 equals plus and minus 6. 2x equals -3 plus or minus 6. 2x equals 3. 2x equals -9. So we're going to have x equals 3/2 and x equals negative 4.5. I did, yeah. Yep. And solve by factoring. So factoring is a really important skill. I'm hoping that you remember how to do it because I'm going to go through rather quickly. In this example, it is in standard form. A is 1, which is my easier kind. So I'm going to think of two numbers that multiply to negative 28 and add to 3. That's going to be 7 and 4. And I need to make the, is that right? Multiplies? Yes, I'm sorry. Make the 4 negative. I'm going to substitute this into factored form. So it becomes x plus 7, x minus 4 equals 0. Now I can apply the zero product property. Which says if you have two things multiplied together and they equal 0, then one of those things, A or B, has to be 0. So I'm going to take my first factor, x plus 7, set that to 0, x minus 4, set that to 0, solve those, so x equals negative 7 and x equals 4. And my 10th example is 8x squared plus 2x minus 15 equals 0. So here notice that a is 8. We want to do what multiplies to a times c. So that's going to be negative 120 and adds to 2. If I start with my 120, that could be 12 and 10. I have to make the 10 negative to make it multiply to a negative, but also add to a 2. I'm going to take those two things and I'm going to substitute it in for my middle term. So I get 8x squared plus 12x minus 10x minus 15 equals 0. Now we have 4 terms, so we can rely on factor by grouping. So I'm going to group the first two and the last two, and I'm going to take the GCF out of each pair. So I can take out a 4x. Remember, when I say take out, it means I'm factoring it out, which means division. So 8 divided by 4 is 2. X squared divided by x is x. And then I had a 12x. I'm dividing by 4x, so I have plus 3. For my second, it looks like I could take out a 5. I'm just going to write a 5 there for a minute and see what's left over. That would be 2x. And I want this to be the same as this. I want this to be a plus. So that means I'm going to do plus 3, which then means I have to take out a negative 5. So I usually do that and wait to see what's coming. Now notice my parentheses are the exact same, so I can factor those out as my GCF, and whatever's left over goes in the other set of parentheses. And here's the zero product property. I set each of those equal to 0, and I get negative 3/2, and I get a positive 5/4. And I have solved that quadratic by factoring. Number 11. Let's try this. It is in standard form. It is set equal to 0. I can take out an x as a GCF. So I have 2x minus 5 equals 0. A lot of students might just say that the answer here is 5/2, but don't forget about this one. That x means something. So here I'm going to set x equal to 0 and 2x minus 5 equal to 0. So x equals 0. And x equals 5/2. A lot of kids will forget this one, but this is a quadratic. It could have two solutions, so don't drop one. In our last example, go ahead and try this one. And I notice that a is not 1, so I'm going to factor by grouping. So I'm going to do what multiplies to a times c, which is negative 24, and adds to negative 5. That would be 8 and 3, and the 8 has to be negative. I'm going to substitute those in for my middle term. So I have 4x squared minus 8x plus 3x minus 6 equals 0. Factor by grouping. So I take out a 4x, leaves behind x minus 2. And then I'm going to take out a 3, and that will leave behind an x minus 2. So that means I'm taking out a positive 3 equals 0. My parentheses are the same, so it becomes x minus 2 in the other factor, and the other parenthesis is 4x plus 3 equals 0. Set each of those equal to 0 so that x is 2 and x equals -3/4. How did you do? Just to recap, solving quadratics part 1, solving means you're finding the x-intercepts. It may have 0, 1, or 2 solutions, real solutions. You can solve by graphing, by finding the x-intercepts, solve by square root, remember to take the plus and minus, solve by factoring, set it to 0, and factor. Good job.